Hello, Honors Algebra. We're going to take a look at our final set of samples for Lesson 9.6, where we're practicing solving quadratic equations using the most efficient strategy. And we're going to round to the nearest hundredth when needed. So our three efficient strategies that we're going to choose from are factoring, taking the square root, and using the quadratic formula. We'll reserve using the quadratic formula for when factoring and taking the square root does not work. All right, let's take a look at our first one. So we have, for sample 1, negative 2x squared minus 8x plus 9 equals 0. And so it looks like it's possible that this could be factored. We're equal to 0 already. We have a quadratic trinomial. And here we are on the side in a thinking bubble thinking through, well, would we be able to factor this trinomial? And the answer is no. We try some possibilities, go through all the possible ways we can arrange the factors of 2x squared and 9, and none of them will give us that middle term of 8x. So we throw out factoring, and taking the square root we're going to definitely throw out because we see both x squared and x terms. So that leaves the quadratic formula. So we identify our a, our b, and our c, and then we plug into the quadratic formula. So we have x is equal to the opposite of 8. So that'll be a positive 8 plus or minus the square root of b squared. So we're going to square negative 8 minus 4 times a, which is negative 2, times c, which is 9, all over 2 times a, which is negative 2. Or we can sing through it. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that'll help us remember what to plug in where. All right, then we're going to simplify into the radical next. Negative 8 squared is 64. And then we're subtracting a negative here, so that means we're going to end up adding. So we simply think 4 times 2 times 9. 4 times 2 is 8, times 9 is 72. So we're going to add 64 plus 72 in the radical. And in the denominator, 2 times negative 2 is negative 4. Notice that our flow is down our paper. We're going to continue to use that format so it's clear that we're using a series of steps to lead to our final conclusion in a very systematic way. All right, so once we add 64 plus 72, we have 136 in the radical. We keep the 8 and the negative 4 outside of the radical where we see them originally. And then we're going to continue with taking the square root of 136 if we want at this point, and rounding to the hundredths place. Again, we're losing a little bit of accuracy taking the square root at this point and only reporting 2 decimal places, but for what we're doing that will be accurate enough. So we have 8 plus 11.66 divided by negative 4 and 8 minus 11.66 divided by negative 4. And on our calculators, we'll see 3 decimal places. We'll round off to the second decimal place, and that will give us x is equal to negative 4.92 or 0.92. Alternatively, if we want, we could have put all of this into our calculator. We'll still arrive at the same answer. 8 plus the square root of 136 divided by negative 4, and the other answer would come from 8 minus the square root of 136 over negative 4. And that will give us a slightly more accurate answer. In this case, comes out the same, but it doesn't always. All right, sample 2. Sample 2, we're seeing both x squared and x terms, and so we are saying, well, taking the square root won't work, but we're considering factoring. We're noticing that our trinomial, quadratic trinomial factoring won't work here. We only have a binomial. And we're thinking, well, is there a greatest common factor that we can factor out of both of these terms? And the answer is yes. So we are going to use factoring here. We're going to factor out 4x, leaving inside 7x minus 8, because 4x times 7x is 28x squared, and 4x times negative 8 is negative 32x. Then we're going to set each of those factors equal to 0 and use the zero product property here to find out the two values of x. So either 4x is equal to 0 or 7x minus 8 is equal to 0. And solving both of those, we'll arrive at x is 0, or x is 8/7. And if we want to divide this out to 1 and 1/7, that's fine, but we're not measuring or graphing with this number, so 8/7 is perfectly acceptable. It is a fraction in fully reduced form. All right, sample 3. On our last one here, we're looking at this squared term, and we're noticing that once we get that squared term by itself, we'd be able to take the square root. So taking the square root will be our method that will be most efficient here. To use that method, we'll need to subtract 7 on both sides first, giving us x minus 5 squared equals 81. Then take the square root of both sides. When that squared term is by itself, that's when it's time to take the square root. Of course, we'll have two roots. We'll have a positive and a negative root. So we'll end up with x minus 5 equals positive or negative 9. We have a nice perfect square here. No calculator is necessary at this point. Then we're going to add 5 on both sides and get x is equal to 5 plus or minus 9. Then we'll break that apart into two separate calculations, 5 plus 9 and 5 minus 9. And that will give us our final answer of x is equal to 14 or negative 4. So we again are practicing solving using the most efficient method possible of our 5 quadratic equation methods, and we're going to concentrate on putting into practice either factoring, taking the square root, or using the quadratic formula, whichever one is the easiest of those three when we're presented with a particular quadratic equation. All right, our next step is moving on to our quiz 9.6e, so make sure that these samples are recorded and make sense, and we'll see you next time.